So 3.3 is about increasing and decreasing functions in this thing we're going to call the first derivative test. All right, so we're going to see this word classify all relative extrema as a min or a max. Now, if you're lucky enough to be given a graph, this should be pretty easy. We have a relative minimum right here on number 1, and these are also absolute minimum. We also have a relative max. And so we've seen these be written as points, and we're going to kind of start writing this out just a little bit. So here, just want to emphasize here that the relative max is 0, and that's happening at x equals 0. The min, all right, we have, I'm going to write it over here, we have the relative min that is negative 1, put a line here, and that's happening at x equals negative 2 and x equals 1. And we can see at these relative mins and maxes, the first derivative would be 0, the slope of the horizontal line would be 0, and the slope is changing from negative to positive and vice versa for the other one. Okay, but what we're really going to be doing now is kind of taking this forward to increasing and decreasing. Okay, so if I split up the graph and I think about it, if I put arrows here, I can see that if I read from left to right, the graph is decreasing. All right, and it stops decreasing right there at that relative min. And so we have f decreasing, and that's happening from negative infinity. It stops at negative 1, but it picks back up right here at 0, and then it stops again at 1. And the reason this is happening is because, or the way we know for sure f is decreasing, is because the derivative, the first derivative, is less than 0, is negative. See how what I've drawn here in blue, the slope of all these tangent lines would be negative. That's what decreasing means. So you may think, oh, the function's still decreasing at x equals negative 1, but it's not. Remember, the derivative is 0 there. So we only are going to say the function's decreasing when the first derivative is negative. Okay, that would mean increasing. I'm going to draw here in green. F is then increasing from negative 1 to 0, and I union that with 1 to infinity. And this is happening because f prime is positive. Okay? Notice that when f is increasing or decreasing is an interval of x's. Okay? And I always write because, and I relate it back to the derivative. Okay, now if I relate this over here to number 2, I might have a min and a max in a different place. Now here, my min is actually above my max. That's interesting. But these are relative mins and maxes, so that's okay. I'm going to go ahead and draw in an asymptote so you can see what this graph really looks like, relate it back to when you graphed rationals. And when we're doing decreasing, okay, so it looks like in the very beginning of this graph I'm actually increasing. So I'm going to go ahead and do decreasing first. It looks like we're decreasing. F is decreasing from negative 2, the x value, and then I stop decreasing at negative 1. In fact, I'm not differentiable at all right there. The function is not. And I pick back up my decreasing after x equals negative 1. You can't just skip over that negative 1. There's an asymptote there. So negative 1, and then I stop again at 0. And again, this is happening because f prime is less than 0. Okay, likewise, my function is increasing at the very beginning of the graph, so I could say f is increasing from negative infinity, and I stop at negative 2, and then I union that over here where I pick up increasing again, and so I union that with 0 to infinity. And that is because f prime is greater than 0. So when f prime equals 0, you're neither increasing nor decreasing. Okay, when f prime is non-existent, in the case of an asymptote, you're not increasing or decreasing there either. Okay, so here we get this definition. And the definition may actually confuse you. And so I'm just going to kind of go over it, but if you understand it so far with what I've done with the examples, you're good to go. So function f is increasing on an interval for any two numbers as long as the y values then are getting bigger, okay? We also have to say that the derivative has to be greater than 0. So I'm going to write that because this is really, this is not the definition, but I really want to bring it back to this. A function's decreasing when the y values are getting smaller, and again, f prime is negative. Okay, derivative of a function that's always increasing will always be positive. Repetition, repetition, repetition. Get it over and over and over. Derivative of a function that's decreasing, well, that'll always be negative. Okay, so derivative of constant function, what this would look like is just y equals 2 or something like that. Well, that function is not increasing or decreasing, and so this derivative is always 0. Okay, and a function changes from increasing to decreasing or vice versa at relative extrema. And so you can get into knowing that if we're going from increasing to decreasing, that's going to put a max right in between there. If we're going from decreasing to increasing, well, that's going to give me a min. And so you can kind of see how this might work out. All right, strictly monotonic. This means the function's always increasing or always decreasing. So an example of this would be really any line. Y equals 2x plus 5, that's a line always increasing. It's a pretty simple example. We also have the good old exponential function. Okay, that function always increasing. Okay, f prime is always positive on this exponential graph. All right, so now we get to this other theorem, and this is going to be our test. So if we have a function that's continuous and we have a closed interval and we have differentiability, the first derivative being positive tells us that we're increasing. So it's kind of just going backwards. Earlier we were saying increasing tells us about first derivative. Well, really, when we do these things algebraically, we know a lot more about the derivative. So we're going to say, okay, well, if the first derivative is negative, we're decreasing, and if the first derivative equals 0, then we have f is constant, and this could be our relative extrema. Now, there could be other things going on there, and we'll explore that later. Okay, so no matter what you do, when I ask you about increasing or decreasing, we've got to find the derivative. Okay, plugging this into our calculator is not an option. So we have 3x squared, and then looks like that 2 cancels out with that 2, and we get 3x. All right, what we need to do is actually find out where this derivative is equal to 0, okay? Basically our critical numbers, okay? And so we're going to let this be 0, and so I'm going to factor out 3x. I'm left with x minus 1. I'm just solving for x here. It looks like my two values for x would be 0 and 1. Okay, so let me scroll here just a little bit. Okay, what I'm going to do is I'm going to place this on a sign chart. When I say sign, I mean SIGN, like plus minus. Okay, put your two numbers right here. Down below, I'm going to write f prime, and up above, I'm going to write f. Okay, so what we're going to do is we see that x equals 0, x equals 1, those could be relative extrema, but we know that it's where the graph is leveling off, okay? We know that these two numbers are what separate increasing and decreasing intervals. All right, so I'm going to take any number over here, so any negative number, and I'm going to plug it into the derivative, all right? So essentially what I'm doing here is, and I'm not going to put y there. I don't want to do that. I'm going to put f prime. Okay, if you take any negative number and you plug it in for x, all right, 3x squared, this is always going to be the larger, that's going to make positive. Now, if you need to actually plug in a -1 and to figure out that f prime is going to be positive, do that. All right, go as far as you need to go. Okay, plug in a negative number, you get a positive derivative. This means that f is increasing, and so I'm going to write it and I'm going to draw a picture. Okay, now I need to take a number in between here, like 1/2. All right, now when you plug 1/2 in for x, what happens when you square a small number? It gets even smaller. And so 3 times a small number minus 3x, that's going to end up giving me a negative. And this is going to cause my function to decrease. All right, now we're going to plug in any number after 1. We could plug in 2, we could plug in 500. It doesn't really matter. You are going to get a positive number in return, so we put a plus there. That's increasing like this. Okay, so we can kind of see the shape that the graph is making. And so the way we're going to write our answer, oops, sorry, didn't want to go down that far. The way we're going to write our answer is we're going to say f is increasing on the interval. We just follow our number line here. Negative infinity, we stop at 0. Looks like we pick back up, increasing from 1 to infinity. And we're going to write a justification. We're going to say because f prime is positive. All right. Likewise, f is decreasing on the interval 0, 1 because f prime is negative. Okay, you've written your answer, and we've written it as into sentence, and we've written justification. Okay, at x equals 0 and x equals 1, the graph is neither increasing nor decreasing. Now, one other thing, it's going to mention this in a second, is you can see that if my graph is going to do something like this, okay, I can see that I have a maximum and a minimum. I have a maximum right here when x equals 0, and I have a minimum when x equals 1. That's what it's saying here. In general, when f prime changes from negative to positive, think about this. Negative derivative is going down, positive is going back up. It's going to cause a minimum. Positive to negative is going up, then going down. That's going to cause a maximum. So we're going to classify the extrema. So what this means is at x equals 0, we have a max. Okay, so our max, I'm going to write it out as a point first, is going to be 0 comma something. Our min is going to be 1 comma something. Now to find these y values, we need to go back up to the original. So we plug in 0 back in for x. Well, we get 0. When we plug in 1, I'm not going to do that number crunching right here, you're going to get negative 1/2. Okay, so 0 and negative 1/2. Now the way we could write this out, because we're about to get to where we're going to have to write it out, write our justification, we would say f has a relative max of 0 at x equals 0. Okay, remember that the first number, and with 0, 0, it's okay if you get them mixed up because they're the same. This is where, and this is what. And so let me show you what this one looks like. F has a relative min of negative 1/2, and that's happening at x equals 1. So it's just refining our answer, putting justification, and we could even go further and give our because really here. We could say there's a relative max because, I'm just going to point right here because we might do this later, f prime changes from positive to negative, okay, and we could do the same thing for our relative min, okay? All right, we're going to do one more example. Okay, so anytime you're giving these, we're going to, by the way, I skipped A and I went to B, so go straight here. So I'm going to do f prime of x equals, I'm going to bring down that 2/3. This is now, it's going to be x squared minus 4. I'm going to give a negative 1/3, and inside parentheses I'm going to put a 2x because I need to use the chain rule here. All right, now I'm going to go ahead and simplify this one. 2 times 2x, that's a 4x on the top, and on the bottom I'm going to have a 3 and a cube root of x squared minus 4. The reason I'm going to do this is because I need to figure out what my critical numbers are. My critical numbers are where this function is 0, where it's undefined. Basically where the numerator is 0, where the denominator is 0. Okay? I'm going to go through this part quickly. When the numerator is 0, that gives me x equals 0. When the denominator is 0, really all I'm concerned about is this inside part equaling 0, meaning I can kind of ignore that. I can multiply both sides by 3, cube both sides, whatever. So I end up getting x squared equals 4, and really my x's then are going to be plus and minus 2. Okay, so let's go ahead and put all these things on a number line. Make sure that you put them in order. And again, we're going to have f prime down here. We're going to have f up here. So you're going to take any number, okay, over here to the left. If I were to plug in any negative number to the left of 2, the denominator is actually going to be positive, okay, as long as this number is larger than negative 2 in the negative direction. So I get negative. Now, if you're confused about this, you need to come ask questions, because this is all arithmetic. Okay, now if f prime is negative, that means f is decreasing. Okay, now when we plug in a number like, say, negative 1, sorry, didn't mean to do that right here. If we plug in negative 1, okay, well, I'm still going to get negative on top, but I'm also going to get negative on bottom. Cube root of negative is a negative, so I get plus. All right, now I'm going to go ahead and just tell you what you get here. Now, it looks like it's always going to alternate. That's not always the case. You could have two negatives next to each other, two pluses next to each other. All right, so let's go ahead and write out our answer. F is increasing, and this looks like we start at negative 2, and we go up to 0, and then we skip over and go to 2 to infinity, and we're going to write because f prime is positive. Okay, f is decreasing. This looks like negative infinity to negative 2, and then we union over to 0 to 2. And this is happening because f prime is less than 0. I could take this further and talk about relative mins and maxes. Okay, right here it looks like I'm going to have a min. All right, and so I'm going to not go ahead. If we plug negative 2 in, like in other words, what is f of negative 2, you end up getting 0. Okay, so I'm going to say f has a relative min of 0 at x equals negative 2 because f prime changes from, remember, f prime here was negative to positive, and this is a great answer. It really can't get any better than this. All right. We also have a relative min of 0 at x equals 2. So I could say at x equals negative 2 and x equals 2. I probably should have put that in there. Okay, likewise, we could say 1 for the max. I'm not going to write that down, but you could do that question as well.